Hello children, welcome to my channel. Now this is chapter polynomials for standard 9. So you have learned the algebraic expressions in standard 8. So we'll just recap what exactly it is. So algebraic expression is a combination of constants and variables connected by some or all of the operations. The operations are addition, subtraction, multiplication and division. And such an expression is called an algebraic expression. So this is an example, 2x squared plus 5x minus 9. So you have variables, you have constants, and it is connected by, here 2 and x is connected by multiplication, and here addition, here subtraction, again here multiplication. Similarly here if you see, this is division. So these are examples of an algebraic expression. Now we are going to do polynomials in one variable. So a general format of a polynomial in one variable is a0 plus a1x plus a2x squared plus etc. an x to the power of n minus 1 plus an x to the power of n. So this is a polynomial of in x, it's in one variable of degree n, where a0, a1, a2 are all real numbers, and if it is a degree of n, then this cannot be equal to 0. An cannot, this term cannot be 0. If this becomes 0, then you don't have this term at all. Then your polynomial will become a polynomial in x of degree n minus 1. So if you want a polynomial of degree n, so that coefficient should not be 0. So this is a general format of a polynomial, and it is very important that n has all these powers has to be non-negative integer. So when you do, we will do some more some examples, so this will become very clear. So let us find out whether these are polynomials. If so, their degrees also. So here it is a polynomial of degree of in one variable, in the variable y, and here if you see, all the powers are positive integers, and the highest power is 4. So the degree of this polynomial is 4. Here if you see, it is 5. Now in this x plus 1 by x, so 1 by x can be written as x plus x to the power of minus 1. So now you have a negative exponent here. So this is not a polynomial. Not a polynomial. Now here cube root of x plus 1. So you can write this as cube root of x is what? You have learned it in the previous chapter. Nth root of x will become x to the power of 1 by n. So this is x to the power of 1 by 3 plus 1. So here if you see, this power is not an integer. It is positive, but it is not an integer. So it is not a polynomial. Coming to this, again you can write this as x minus 1 into x plus 2 into x to the power of minus 1. This will become into x to the power of minus 1. So again you have a negative integer. So this is also not a polynomial. So here also x is in the denominator. So this is also not a polynomial. Coming to this, see immediately when you see this, it is root x. So x to the power of half. So it is not an integer. So immediately you should not say it is not a polynomial, because now you have to simplify this. So this denominator we will do it separately. So 6 root x by root x plus x to the power of 3 by 2 by root x is x to the power of half. So this root x and root x get cancelled, and here 3 by 2 minus 1 by 2 will become 2 by 2 it is 1. So it becomes x. So this expression reduces to 6 plus x. Now this is a polynomial, because your degree is 1 here and it is positive. So it is a polynomial of degree 1. So here In this question it is 1 by 4 x to the power of minus 2. So, we can rewrite this as 4x square, sorry, 1 by 4, this 1 by 4, x to the power of minus 2 will be go to the numerator. So, x squared plus 3x plus 5. So, now all the powers are positive integers. So, it is a polynomial of degree 2. Here if you see, this x to the power of 2 is in the denominator. So, it goes to the numerator. So, it is not a polynomial. It becomes x squared plus x to the power of minus 2 plus 2. So, it is not a polynomial. So, I hope you are now clear whether to identify whether it is a polynomial or not. Now, we will go to the zeros of a polynomial. So, let Px be a polynomial, and if P of alpha, you substitute some value for x, that is alpha, and you get the polynomial equal to 0. If P of alpha is equal to 0, then alpha is the 0 of the polynomial. So, I will explain with an example. So, here the polynomial is given as x plus 2. Now, we have to check whether minus 2 and 2 are zeros. Zeros means the value of x such that P of alpha is equal to 0. So, we will here we will substitute. So, here we have to substitute minus 2 here and see whether this value becomes 0 or not. If it is becoming 0, then it is this minus 2 will be a 0, and similarly 2 also we have to substitute in the value of x this minus 2 and 2 and check whether you are getting f of x is equal to 0. So, here f of x is equal to x plus 2. So, we will substitute x we have to check whether 2 and minus 2 are zeros. No? So, we will substitute x is equal to 0 in this. So, f of 2 is equal to 2 plus 2 equal to 4. So, not equal to 0. So, it is not a 0. Now, here f of x is equal to f of minus 2. We will substitute in the place of x minus 2 plus 2. So, equal to 0. Now, you are getting f of minus 2 equal to 0. Therefore, minus 2 is a 0 of the polynomial. Hope it is clear. Now, we will find how to find the z. Here it is all the zeros are already given and we are checking whether it is 0 or not. Now, we have to see find out how to, we will see how to find out the 0 of the polynomial. So, to find the 0 of the polynomial, you have to simply equate the polynomial to 0. For example, find the 0 of the polynomial Px is equal to 3x plus 2. So, we will equate this to 3x plus 2 equal to 0. So, from this you will get 3x is equal to 0 minus 2. So, minus 2. So, x is equal to minus 2 by 3. So, the 0 is minus 2 by 3. So, here in this polynomial we will equate 5 minus 4x is equal to 0. So, 5 equal to 4x. So, x is equal to 5 by 4. So, the 0 of this polynomial is 5 by 4. Now, we will discuss about the division algorithm. So, you know the normal division. Take this example, 25 divided by 4, you get 6 as a quotient and 1 as a remainder. So, how do you write this? You can write 25 is equal to 6 into 4 plus 1, that is dividend is equal to quotient into divisor plus the remainder. So, suppose we are giving now we are going to do with the polynomial. So, let the dividend be Px, the divisor is Gx, the quotient is Qx and the remainder is Rx. So, Px divided by Gx, so you get Qx as the quotient and Rx as the remainder. Now, we will discuss about the degree of the divisor, quotient, remainder and all. So now the degree of Px is the dividend, is always greater than the degree of the divisor, and degree of the remainder will be always less than the degree of the divisor. See here you will get remainder of, you can have remainder of only 1, 2, 3. See 4 means again it will become, you can divide it. So your remainder is always less than 4. Similarly the degree also will be always less, degree of the remainder also will be always less than the degree of the divisor. So now we will do the division. We will learn how to divide these two polynomials, and we will also verify using this division algorithm. Division algorithm is nothing but dividend is equal to divisor into quotient plus remainder. So the first thing that you should remember while dividing is, you have to always write the polynomial in the descending order. Whatever be the order it is given, you have to first write in descending order, and similarly even the divisor has to be written in descending order. And now x cube is the first term. So our what we will be doing is, we will be eliminating each term from the left side. So here x into something, some variable, you will get x cube. So what is that variable? It is x squared. If you multiply x squared with x, you get x cube. So we are going to make it same, make these terms same, so that you can, when you subtract, this will get eliminated. And now you have to multiply, you should not forget to multiply x squared with 2. So plus 2x squared. Now you subtract, this will get cancelled, it will become 0, plus x squared minus 2x squared, that will become minus x squared. 1 minus 2 is minus x squared. Then we will bring this down. Now with x you multiply some variable, so that you get minus x squared. So that is minus x, you multiply x with x, you multiply minus x, you get minus x squared. So minus x squared, then minus x into 2 will become minus 2x. Now again subtract, these will get cancelled. Now you are left with now 2x minus minus 2x minus minus 2x. So it will become 4x plus 4x. Then we will bring down this 3. Now you have to multiply x with 4, so that you get the same coefficient, the same term. So it is 4, so 4x. Now 4 into 2, 8. So plus 8. So 3 minus 8 is minus 5. Now we will verify it. So for verifying, we have to verify the dividend, as that is x cube plus x squared plus 2x plus 3 is equal to divisor into quotient. So x plus 2 into x squared minus x plus 4 plus the remainder minus 5. You have to verify this. So we will take RHS and do the multiplication. X cube minus x squared plus 4x, x into 4, then plus 2x squared minus 2x plus 8, then plus minus 5 becomes minus 5. So this is equal to x cube, then minus x squared plus 2x squared will become plus x squared, then 4x minus 2x will become plus 2x, then 8 minus 5 will become plus 3. So this is equal to LHS. So hence verified. Now we will do one more problem of division. We have to divide the polynomial x to the power of 4 plus 1 divided by x minus 1. Now here you have only x to the power of 4 and then a constant. You don't have x cube, x squared and x term. So what you have to do is, when you don't have, if any of the terms are missing, we will write as 0x cube plus 0x squared plus 0x and then plus 1. Then you will find it easy to do the division. Otherwise it will be slightly difficult for the beginners. So please write down the remaining terms like this and then continue. Now we will start x into x cube, you will get x to the power of 4. So we will write x to the power of 4. Now x cube into minus 1 minus x cube. So we will write down below minus x cube. Now subtract 0 minus minus 1. 0 minus minus 1 will become plus. So this will become x cube. Then we will bring this 0x squared. Now we will multiply with x into x squared, we will get x cube. So x cube, then x squared minus 1 will become minus x squared. Again x squared minus minus x squared, so plus. So it becomes 2x squared plus 0x. Again bring this 0x down. Now we will multiply with plus x into 2x, you will get 2x squared. So if you see, we are eliminating each term and proceeding. So minus, now 2x into minus 1 is minus 2x. So 0, again 0 minus minus 2 will become plus 2x. Then we will bring the constant down. So now x into, so plus 2. Sorry, here it is 0x squared minus minus, so it is only 1x squared. I am so sorry. It is 1x squared. 0 minus minus 1 is plus x squared. So this also will become, you have to multiply with plus x only, 1x. So this is also 1x. So this will become x, 1x into minus 1 will become again minus x. So this is not there. So minus x. So x minus minus x, sorry 0x minus x will become plus x. So this 2 is not there. Hope it is clear. So we have to know this is also not, you have to multiply with, now you have only x. So you have to multiply with 1 only. So x plus 1. A small mistake here, we had to adjust so many places. So be careful when you are doing. Hope it is clear. Here you are multiplying with x into x, x squared minus x, x squared minus x. This 2 is not there. So then 0 minus minus 1 will become 1, 1x, or 0 minus minus x will become plus x. Then you are bringing down 1 and then 1 into x, x. Again 1 into minus 1, this is minus 1. So you are getting a 1 minus minus 1 will become, you will get a remainder of 2. Now we will verify it and see. So x to the power of 4 plus 1 is equal to x cube plus x squared plus x plus 1 into x minus 1 plus 2. So RHS is equal to, we will multiply each term. So you get x to the power of 4 minus x cube plus x cube minus x squared plus x squared minus x plus x minus 1 plus 2. So these everything gets cancelled, this will get cancelled, this and this will get cancelled. Similarly this will get cancelled, again this is getting cancelled, and you are left with equal to x to the power of 4 minus 1 plus 2 will become plus 1. So that is equal to LHS, hence verified. Hope this division part is very clear. So we will continue with factor theorem and remainder theorem in my next video. So keep watching, keep practicing. Bye.